All right, let's talk about something in math that looks super simple, but is actually full of traps. I'm talking about linear inequalities. They're a huge part of algebra, they pop up everywhere, but man, they trip so many people up. So let's dive in and figure out why.
Okay, look at this. This right here is the heart of the confusion. You've got an equation on the left and inequality on the right. They look like they're practically the same thing, right? The only difference is that one little symbol in the middle. But trust me, that tiny change makes a huge difference in how they behave. So what's the deal? Why are they so different?
The best way to think about this is to imagine inequalities as the deceptive twin of equations. Seriously, for a while, they look and act exactly the same. You solve them the same way, you treat them the same way, and that similarity can be pretty helpful. But it's also setting a trap. It's the reason almost everyone makes the same mistake. So let's get back to basics for a second. An equation, that's all about perfect balance. This side equals that side. Done. But an inequality, that covers pretty much everything else. It's not about being exactly equal. It's about saying one thing is bigger or smaller, or maybe bigger or equal to another. It's defining a whole relationship, not just one single balanced point. And here's that deception I was talking about, right in front of us. Look at the equation. We subtract 5 from both sides. Easy peasy. We get x equals 5. Now look at the inequality. We do the exact same move. Subtract 5 from both sides, and we get x greater than 5. See? The process feels identical. And that's exactly how it tricks you. It makes you feel like you know exactly what you're doing. But this is where the story takes a turn. Adding and subtracting, yeah, that's fine, no problem. But what happens when we need to multiply or divide? Now we're getting to the good part. This is where our deceptive twins finally show their true colors. Okay, pay close attention, because it all comes down to step 3. We've got negative 4x is greater than or equal to 12. Simple enough, right? To get x by itself, we have to divide both sides by negative 4. And this is the twist. When you multiply or divide by a negative number in an inequality, you have to do something that feels totally unnatural. You flip the sign. The greater than or equal to symbol becomes less than or equal to. This is the big rule. If you remember one thing, remember this. And hey, don't feel bad if this is new to you or if you've messed it up before. You're not alone. Researchers have actually studied this, and guess what they found? This exact rule, forgetting to flip the sign, is one of the most common mistakes people make. It's the #1 trap. But the good news is, now you know exactly what to look for. But why? Why do we have to flip it? It seems so random, but it's not. Just think about it with simple numbers on a number line. Okay, we all agree 4 is greater than 2, right? It's further to the right. But what happens if you multiply both of those by -1? You get -4 and -2. Now which one's bigger? Well, on the number line, -2 is now to the right of -4. So -4 is less than -2. See? The whole relationship flipped. The rule isn't making something up, it's just describing what actually happens to the numbers. Okay, so that sign flipping thing is a big deal, but it leads to another massive difference between equations and inequalities. When you solve a simple equation, you get one answer. Boom, x equals 5. The end. But with an inequality, your answer isn't just one number. If x is greater than 5, well, that could be 5.1, it could be 6, it could be a billion. It's an infinite number of possibilities. And we have a name for that whole range of answers. It's called a solution set. So how do you even show an infinite answer? Well, we graph it on a number line, and there's a really simple code to it. If you see an open circle, that means the number itself isn't part of the answer. That's for your strict less than or greater than symbols. But if you see a solid filled-in circle, that means the number is included. That's for less than or equal to or greater than or equal to. Simple as that. And this idea gets even cooler when you have more than one inequality to deal with at the same time, what we call a system. It's actually pretty straightforward. You just handle each one individually. Graph its boundary line, shade the part that works. Then you do the same for the next one, right on the same graph. And the final answer? It's just the spot where all of your shaded areas overlap. That's the zone where everything is true at once. All right, I know this can feel a little abstract with all the X's and Y's, so let's bring it back to the real world. Let's talk about Christy. She's setting up a booth to sell her photos, and she's got a few rules she needs to follow, some goals and some limits. Believe it or not, this is a perfect job for inequalities. So here are Christy's rules for herself, and I want you to listen for the key words here. She wants to display at least 25 photos,
and she can spend no more than $200. See? Those aren't exact numbers. At least and no more than, those are boundaries. She's setting a floor for her photos and a ceiling for her budget. And that is what inequalities are all about in real life.
And watch how easily we can translate her real-world problem into math. At least 25 photos? That just becomes x plus y is greater than or equal to 25. No more than $200? That's 4x plus 10y is less than or equal to 200. And just like that, her business plan is now a math problem, a system of inequalities to be exact.
Now, when we put those two on a graph, we get this shaded area, the solution region. And this is the cool part. Every single point inside that shaded area is a winning combination for Christy. It's a mix of small and large photos that hits her photo goal and stays within her budget. It's not about finding one single right answer. It's about seeing this whole landscape of options that will work for her.
So, let's put it to the test. What if she wants to display 20 small photos and 10 large ones? Is that a good plan? Will it work? All we have to do is check, is the point 2010 inside our magic shaded area?
And yep, it absolutely is. Because the point 2010 is inside that solution region, we know for a fact that it works. It meets both of her rules. And notice, we didn't have to plug anything back into the formulas. We could just see the answer. That's the real power of graphing these things. All right, let's boil this all down. Case closed. Here's what you need to remember. First, inequalities are like equations' tricky twin. They look similar, but their answer is a whole range of numbers, a solution set. Second, they play by the same rules, except for that one massive twist. And what's the twist? You've got it. You have to flip the inequality sign whenever you multiply or divide by a negative number. If you can remember that, you've pretty much cracked the code. Because at the end of the day, this isn't just about math class, right? Inequalities are everywhere. They describe all the limits and the options in our real lives. Think about it. Speed limits, your phone's data plan, the minimum grade you need to pass a class, a project budget at work. These are all inequalities. So my question for you is, where do you see them? What are the hidden inequalities that shape your day?